Welcome to GMAETS 41's YouTube channel. In our class today, I'll be teaching you something important in chemistry. We are going to look at valence electron, the second part of it, where we shall give attention to how we can use the knowledge of valence electrons to determine the valency and chemical formulae of compounds. In our previous class, I introduced you to part 1 of this aspect of chemistry. Like I said, this is actually under atomic structure, okay? Because it is from there that we actually introduce the concept of valence electron. In our previous class, you learned how you can use the knowledge of valence electron to identify metals and non-metals, as well as the group of an atom or the group of an element. So today we are moving forward, okay? Ahead. There is no time to deal with further application of the knowledge of valence electron. So once again, I say welcome to join this class. Once you join the class, you know what to do. Share the link to this class to your friends. If you belong to any science group, what stops you of sending the link to this live class to that group so that your friends can join this class? Because this topic targets those in grade 10, grade 11, grade 12, which we refer to as SS1, SS2, SS3 here in Nigeria, okay? Year 10, year 11, year 12, from wherever you are connecting to the class from. And of course, not to forget our dear university student, those in 100 level. I've always said this, your curriculum is simply, grade 10, grade 11, grade 12 works put together. So all of these ones, they need this class, and so invite them to join the class, please. No time. You're welcome, and we are getting to business of our class today. Don't forget that we say that valence electron is the number of electron or electrons in the outermost shell of an element. So maybe if I have something like magnesium, if I have magnesium, we can say that, okay, in drawing the atomic structure of magnesium, the first shell will carry 2 electrons. If I call this the first shell K shell, it carries a maximum of 2 electrons. The second shell will carry 8 electrons. We are talking about magnesium, and magnesium has, 12 electrons because magnesium is atomic number 12. This is the L shell. And then we have to introduce another shell, which will now carry extra of 2 electrons. This is shell N. These shells can be represented by our principal quantum number. Remember, I said I'm not going to talk about that yet. We shall have a class where we discuss the quantum numbers. The principal quantum number, the azimuthal quantum number, the magnetic quantum number. These 3 most important quantum numbers that describes an electron completely. Then, of course, the 4th one, which is the spin quantum number. We'll talk about those quantum numbers anyway, but not in this class. It's not your time. I only just mentioned, quantum number, just to tell you that these shells you're saying, we can use principal quantum numbers to represent them. Like the first one is n equal to 1. The second one, the principal quantum number is n equal to 2. The third one, the principal quantum number is n equal to 3. So this is magnesium atom, Mg. The atomic number of magnesium is equal to 12. Now you notice the number of electrons in the outermost shell, called the valence electron, is 2. The electronic configuration of this atom you're saying is 2, 8, 2. Explained all this in our previous class. Electronic configuration, which is the number of electrons in each shell of an atom. And then going forward, you see that the valence electron, which is simply the number of electrons in the outermost shell, in the valence shell, in the ultimate shell, is equal to 2. Look at it. That guy is very important. And I have always told you, don't joke with the valence electron. So how can we use the knowledge of valence electron to understand valency? So as we start our class, let us define what valency is. What is valency? I've just shown you this, at least as a starting point, so you remember how to draw your atomic structure, because you need it to be able to help you remember your valence electron. And then from the valence electron, we can extend our knowledge further into other important aspects of chemistry. As a matter of fact, if you're in grade 10, grade 11, grade 12, and you don't know this, you've not learned this already, then you are having serious challenge in chemistry. Here on the GMAT 41's platform, I solve these problems for you, friends. And of course, for those that live in Oka, Anambra State, you can also register with our school, GMAT 41 Special Science College. We just established that. It's kicking off this session, and of course, we have already kicked off. But we are resuming in earnest from 13th of this September. Contact us and register with our school. What is valency? We define valency as the combining power of an element. The valency of an element is defined as the combining power of that element. I hope you have your pen and your paper with you. Whenever you are coming to the GMAT 41's YouTube channel, remember, you are coming to learn and learn. Understand science, breathe science, and speak science. So you must come with your writing material, very important. Because our notes, sometimes I dictate them, sometimes I might just write them on the board. You should know the definition of valency. Your examiner wants you to know that. WAEC wants you to know that. JAM wants you to know that. NECO wants you to know that. NAPTEP wants you to know that. Your professional exams, if you are from any other country, want you to know that. I know about the Indians. I think they take this NEET examination or something, right? Yeah. You need to know the definition of valency, the combining power of an element. So if I have this element, and both of them wants to combine, they don't just combine. They must have a power. Each of them must have something with which it can use to combine. You cannot come empty-handed ordinarily to want to combine. There is something that you must have that can initiate combination. So that thing is what we call the combining power of an element, and we refer to it as valency, the combining power of an element. Now, metals have their valency, non-metals have their valency, which means when metals are reacting, there is something, a number that it uses to combine. When non-metals are reacting, there is a number they have with which they use to combine. So the next question would be, what is the valency of metals? And what is the valency of non-metals? We shall answer that. And I hope you are ready. Meanwhile, before we move on, let me just write this. This is defined as the combining power. The combining power of an element. And like I said, metals have their combining powers, their valency. Non-metals also have their valency. So what is the valency of metals? How do you identify valency of metals? Valency of metals. The valency of metals is simply positive, the valence electron. La la. Quite interesting, isn't it? Positive, the valence electron, which means to understand the valency of metals, we need to know the valence electron of metals. So if I give you any metal and I ask you what is the valency, what is the combining power of that metal, it is simply positive of the number of electrons in the outermost shell of the atom of that metal. And so simply put, not to speak too much grammar, the valency of a metal is positive. The number of electrons in the outermost shell is positive, the valence electron. Valency of metals. This is positive. This is positive. Permit me to use this as positive. No time. Are you following right? This is positive, the valence electron. The valence electron. This is positive, the valence electron or electrons. I hope this has not cut off from your view. Let me check the camera that it is still within view. All right, it is within view. Wheel gear, you just typed something here. Let me read out what you wrote. Valence. Valence is the combining power of an element. Thank you for defining that. However, I want to correct this. I always tell students to be careful when they are pronouncing valency and valence. That is why anytime I want to pronounce this guy, I stress the ending sound, the E sound, valency. This is valence. Now, what you defined as valence, which you said it is the combining power of an element, please, that is not valence. Valence simply means outermost. Valence simply means outermost. So you may have to revisit what you wrote there. It's meant to be Y. It's meant to be Y. Look how we're talking about valency. Valency is something that happens. Valency, Y at the end, see Y, is something that happens, which is known as the combining power of an element. Valence, as you typed there, simply means outermost. All right, so I hope I have clarified that. And you want to take note of that, please. Don't confuse valence with valency. An examiner can ask you to define valency, but an examiner cannot ask you to define valence. No. Valence like that, no. This valence, if they want to ask you anything related to it, they must link it to something else. Maybe an examiner can ask you define valence shell, or what are valence shells. Or an examiner can ask you to define valence electron or valence electrons. No one rightly can ask you to define valence. All right? So you take note of that. Valency of metals, I said it is simply positive, the valence electrons. So if a metal have, let's say, 2 electrons in the outermost shell, then the valency of that metal is positive 2. For example, I drew the atomic structure of magnesium before this class, and you found out that the valence electron, the number of electrons in the outermost shell, is 2. So that guy is a metal. Because in our previous class, I taught you how you can use valence electron to identify metals and non-metals. If valence electron is either 1 or 2 or 3, that element is a metal. So magnesium I drew earlier is a metal. It has 2 electrons in the outermost shell, valence electron. Therefore, the valency, the combining power of magnesium is +2. When that guy wants to react, that is metals, that is magnesium. When magnesium wants to react, it usually comes with that 2 electrons. Dear friends, this is GMAETS 41. I believe in the philosophy, all these things we read. People did not just, all these things we study rather, people did not just wake up and learn all of them once. No. It is just from one point. They start expanding. Or the Federal Bureau Investigator, now that US has, okay, FBI. Most times, they don't have the whole facts before they start investigating a matter. Just a little thing, a little point, a little idea, they can start building on it, and before you know, they have exposed everything connected to a particular problem. The same thing you see in your studies. It's important for you to understand that each topic you learn has a key point. That once you grasp that point, boom, you explode, right? Your knowledge, the network of your brain will skyrocket to start breaking down every other part of the subject. Here at GMAT 41, I am dedicated to continuously revealing this secret. Make sure you always stay tuned. You can always think of how you can support this channel so that I would continue to give my best to you friends, especially those of you that are far away from us and not in Oka, or you're in another school. Perhaps you're in Oka, but you're in another school. You have not joined us, or you did, right? Or maybe there is no opportunity of joining our physical school. But for those that have the opportunity, please, like I said, register with GMAT 41, Special Science College in Oka. If you're in Oka, Anambra State, is that okay? We'll teach you, we'll coach you, you will breathe and speak science. You will love learning. Because like I said, all of these things, they are 1 + 1, as long as you are able to understand the secret. And the secret is embedded in GMAT 41. That's the truth. And that's why every time I can always come out here to deliver this top-notch knowledge to you friends. If magnesium has 2 electrons in the outermost shell, the valency of magnesium will be +2. Now, I was trying to say something. Understanding that the valency of magnesium is +2 can now take a student into this topic we call chemical combination. Right? Because when elements, atoms combine, when they react, it is their valence electron that reacts. It is the valence electron that, they exchange. Either they will lose it, or they will gain more to it, or they will share. So you see why GMAT 41 has decided to spot all this part. This part is very hidden when you are dealing with atomic structure. But it is powerful. And you don't play with it. Positive, the valence electron gives you the valency of metals. Now let us look at some example, e.g. we can talk about the valency of elements like sodium, potassium, magnesium, aluminium. Maybe let me give you sodium, magnesium, and aluminium. All right? E.g., valency of sodium, magnesium, and aluminium are +1, +2, and +3, respectively. And once you know their valency, once you know the valency of an element, you have actually known the ionic form. You have known the ionic form of that element. Because when atoms react, they form ions. And if you're writing any ion, the ion must carry what is called electronic charge. The electronic charge of any element, which is an ion, the electronic charge of the ionic form of any atom is the valency of that element. You can see how important what we are doing here is. Please do not play. Don't joke with all these things. You may not have the opportunity of getting this knowledge from your various schools. You may not have the opportunity. Mark my word, may opportunity here. Make sure you get the best from this platform. Your exam bodies, WAEC, NECO, JAM, they won't play to find out whether you have been taught this topic or not. And you can see I am particularly happy of the way exam bodies are trying to tighten up, any room of engaging in malpractice. I guess also they should try a way to look into our schools, private schools, all right, public schools, especially private schools. Yes, especially private schools. But I'm happy, like for JAM, in as much as there's something they have done recently, they messed up in an exam they conducted April, May this year. That does not in itself, all right, condemn them completely. if not for anything, the body is doing their best to make sure they reduce the excesses of examination malpractice, and kudos for them on that. WAEC has joined forces already. We are all aware that here in Nigeria, WAEC, they are going for, they've transferred their exam format to CBT, and that, of course, helps to reduce as much as possible examination malpractice. So why am I saying this? You just have to learn. You just have to learn. We cannot be complaining of corruption at almost all levels, and from the ones we can control. Examination malpractice is corruption. Perhaps it's part of where we start learning corruptions from, right? But I used to know that in the Nigerian law, at least years ago when I was in school, that stuff is punishable by, I think, 14 years or 21 years of imprisonment there. You have to learn. Don't do that for whatever I'm saying. Do it for yourself. It's for your best. And you know your parents are really spending a lot to pay your fees. Please, let's move on. Let's talk about the valency of nonmetals. Valency of what? Non-metals. How do you get the valency of non-metals? Simply, the valency of non-metal is obtained from subtracting the maximum number of electrons that the shell can contain from the valence electron. Do you understand that grammar? The valency of nonmetals is obtained simply by subtracting the maximum number of electrons that a shell can contain from the valence electron. So this is it. Generally, we know that most shells, the maximum they can contain, maximum number of electrons they can contain is 8. Is 8. Sorry, I'm trying to say, I hope this is not hanging. Yeah. The maximum number of electrons they can contain is 8. So if I want to get the valency of nonmetals, what I will do is to subtract that 8 from the number of electrons in the outermost shell of the nonmetal. You subtract 8 from the valence electron. That is simply what it is. And most generally, the valency of nonmetals is negative. That of metals is positive. That of non-metal is negative. Because whenever you do that valence electron minus maximum number of electrons that the shell can contain, which, like I say, most generally is 8, the result you would always get is a negative result. I'm going to write that here. Valency of non-metal. This is obtained from subtracting 8 from the valence electron. The valence electron of the non-metal. So generally speaking, this is how you get the valency of non-metals. Like I say, it is usually negative. It is usually negative. Okay? I'm going to give you a note after I give you examples here, because there are cases where the valency of non-metals can still be obtained the way you obtain the valency of metals. I repeat that. There are still some cases that one can obtain the valency of non-metals exactly the same way you get the valency of metals, which is simply positive, the number of electrons in the outermost shell, positive the valence electron. But that is not a usual case. That is not the usual case. It is not the fundamental way of getting the valency of non-metals generally. I've told you the general format, how you obtain the valency, the combining powers of non-metals. So I'm going to give you an example, e.g. Let me make use of this part. Let us think about the valency of, maybe I might just scatter it, okay, the valency of, let's say, chlorine, valency of oxygen, and then valency of nitrogen, okay? So, e.g., valency of chlorine, comma, oxygen, and nitrogen are -1, comma, -2, and -3 respectively. The respectively means in that order. The valency of chlorine is -1, the valency of oxygen is -2, the valency of nitrogen is -3. Okay, I hope this did not cut off from view. I think I have to adjust the camera just a little, right? Oh no, I just hope. Just a little, okay. Fine. That's good. How do we know that the valency of chlorine is -1? Quickly think of the valence electron of chlorine. The valence electron of chlorine is 7. 7. So if the valence electron of chlorine is 7, subtract 8 from it. 7 minus 8 will give you -1. Therefore, the valency of chlorine is -1. And remember, I told you, once you know the valency of any element, you have actually gotten, or you've known the ionic form. For example, in ionic form, chlorine is written like this. This is -1. For 1, we don't show it. Simply write the valency in power form on top, in exponent form, in index form. That's it. So this is ionic chlorine in ionic form. If chlorine reacts, this is how you write it in ionic form. Oxygen is written this way. These are things that most of you in the science field see, but sometimes you just may not understand how they came about. But you can see as you're learning from this class, there is actually 1 + 1. All of them, they take root from atomic structure extended into picking that piece called valence electron. Let's talk about nitrogen. Generally, nitrogen is written like this. When it reacts, the ionic form. As an atom, if it is an atom, chlorine atom, oxygen atom, nitrogen atom, you don't show the ionic charge. You don't show the valency. And we have talked about that in previous classes. Okay, so you can take such lesson. You can take the lesson rather we've covered in previous classes. Remember, we have a timetable guiding these online evening classes from GMAETS 41. Yes, we have a timetable guiding it. Monday, Wednesday, Friday. I come on live by 8 p.m. or sometimes 8:30 p.m. Nigerian time, West African time. So if you want to learn, you don't want to miss out in all this important top-notch knowledge coming out from GMAETS 41, make sure you always stay tuned and connect once it is 8 or 8:30 p.m. Now, for you to be notified to receive personalized information about our classes, if you have not subscribed yet, you are not doing well. Yes, you subscribe, you are supporting me how to build our community. That's appreciated. But you're also helping yourself. But let me still tell you, after you subscribe, it's not sufficient to get more benefits. Not to miss out in any class. If you subscribe, go ahead and click the notification bell. Like I said, all these are for your own good. Thanks to YouTube, they have created this platform for us, for you. So after you subscribe, you have the bell icon besides. Click it. If you click it, a menu will open. You will see all, personalized, and some other write-up. Select all. The reason for that, YouTube has created it such that after you subscribe and you turn on the notification bell, select all. Whenever I come on live, you will be notified immediately by YouTube. So you won't have to miss out on any of the class because we have a timetable guiding us, and not just a timetable, we have a scheme of work that is guiding us. Like I've always said, every year, GMAETS 41 intends to cover your science work, mathematics, physics, chemistry, and soon biology to kick off. I've been talking about that. English is not on this channel. It's in our basic channel because I feel like English is a language and it does not really respect any level of learning generally. That's the truth. I don't know what you think. But for these 4 other subjects, there are key sciences here on this channel. So don't miss out, please. Today is Wednesday. You're enjoying chemistry now. On Friday, we shall be taking on physics. I know we are dealing with vectors in physics. Mondays, mathematics. Please, let's continue with our class. Now we have seen how we can use the knowledge of valence electron to determine the valency, the combining power of an element. I'd like to bring out this note for you, please. This note is applicable to non-metals because sometimes your exam bodies can ask you this question. You have learned already from GMAT 41 that the valency of non-metals, the combining power of non-metals, is obtained by subtracting 8 from the valence electron. How about I give you an exam question, or your examiner gives you an exam question and asks, what is the valency or what is the combining power of nitrogen, for example? And then in the options, you have A, 2, B, -2, C, 3, 4, okay, let me remove this 3. I can even put the 3. Yeah, 3. What is the correct answer here? The combining power, the valency of nitrogen. A moment ago, you saw me as I wrote it on the board here. Likely, some persons may go for option C. But unfortunately, option C is wrong. The combining power of nitrogen is not 3. If it must go with 3, it will be -3. Because for it to be 3, you have to subtract 8 from the valence electron. And the valence electron of nitrogen is 5. So if you do 5 minus 8, you get -3. That of oxygen, valence electron of oxygen is 6. If you do 6 minus 8, you get -2. That's how I came up with this. Chlorine, I've told you already, valence electron 7. 7 minus 8, you have -1. The correct answer here, the combining power, the valency of nitrogen, as given in this option, the correct answer is option D. I wrote for you option D. That is the correct answer. Option D. And you may wonder why. Remember that this option D is plus. That's why minus was written there. So it's important for you to take note of what I'm about to write here. And like I said, it applies only to what? Non-metals. Sometimes, the valency of non-metals. The valency of non-metals. Remember what I told you about 3. For you to see 3, it should go with minus. I don't know, maybe if an examiner could give such option and leave 3 as positive, something like this. But if any examiner does that, I think I can say categorically clear and unapologetically that leaving the option as +3 like this is wrong. Because for non-metals, we indicate the sign. The sign is what differentiates combining powers of metals from non-metals. Why metals are positive, non-metals are negative, using this general and fundamentally accepted procedure of getting valency of non-metals. If you want to write valency of non-metals as positive, it goes through the way you obtain that of metals. That is why I told you in this case for nitrogen, the correct answer would be 5, which is positive, the valence electron. So I want to indicate this, very important for you to take note of. Sometimes the valence electron, okay, the valency of non-metals can be obtained similar to metals as positive valence electron. Positive valence electron, e.g., look at oxygen, e.g., oxygen. Okay, let's write nitrogen, oxygen, right, have +5. and plus 6. Plus 5 and plus 6, respectively. Good. Respectively. So you want to take note of this point. In case you see a place where the valency of non-metal is given as positive, please, it will simply be positive the valence electron. Like for nitrogen now, it is plus 5. For nitrogen, it is plus 5. And that happens in compounds or in compounds that have the trioxonitrate 5 ion, or that has the trioxonitrate 5 radicals. Yeah. If you pronounce tetraoxosulfate 6, where you calculate oxidation number. The sulfate 6 there, that 6 is having oxidation number of plus 6. And that goes with the valency of sulfur going in the positive direction. Just like the way you obtain that of non-metals. So you want to remember this generally. I can give it as a rule of thumb. The valency of any element, be it metals or non-metals, is positive valence electron. I repeat, generally speaking, just as a rule of thumb, okay, have this in mind. The valency of any element, whether it is metal or non-metal, is plus, that is positive, the valence electron. Positive, the number of electrons in the outermost shell. If you now want to be quite specific, to differentiate between metals and non-metals using the mathematical operation plus and minus, non-metals go with minus. Where in that case, to get the valency with minus, it is going to be the number of electrons in the outermost shell, valence electron, minus 8. And that is the format, that is the procedure, all right? The standard that is generally acceptable, or accepted rather. That is the format that is generally accepted, where you do number of electrons in the outermost shell minus 8 for non-metal. So at least let that one stick to your brain, okay? The final thing I say generally is just have that in mind in case an examiner wants to terrorize you sometimes with such kind of question, like I showed you of that of nitrogen a moment ago. All right, so we are done with this. I think I have a question here. Will Gia explain again on valence and valency? Simply put, valence, that which spelling ends with CE. CE means outermost. Means what? Outermost. So you could hear something like valence electron. Valence electron. You could hear something like valence shell. But valency is a combining power. That's number that an element must possess to help it combine, to help it react. Okay? We refer to it as the combining power of an element. That is valency. Don't pronounce this. Look at this guy, VA. Whenever you're pronouncing it, you want to be careful. This is valence. Valence. You don't stress the end. No, you don't stress it. And then this is valency. Valency. You notice I stressed that ending part. The phonetic sound there. The transcription of this E sound is long E sound. If you're learning your phonetics, right? Meet us in GMAETS 41 basic class channel for all of this about English. Valency. And this is valence. This one means outermost, the last thing. Are you following? And this one means valency. While an examiner can ask you to define valency, an examiner cannot ask you to define valence. It makes no sense. But you can be asked to define valence electron. You can be asked to define valence shell, which means outermost electron or outermost shell. I think I've answered your question, Will Gia. Antares 444, sir, is the number of electrons in last shell of that atom, is it the valency? Is the number of electrons in the outermost shell of an atom known as valency? One has to be careful with that. One has to be careful with that. Please, standard, generally accepted around the whole world. If you hear valency of an element, it is a combining power of that element. Now, we break it into two parts: valency of metals and valency of non-metals. Valency of metals is the same with the question you asked. Valency of metals is the number of electrons in the outermost shell. It goes with positive. Whether I like put positive or not, I usually talk about the ionic form, so that I usually talk about the sign, positive or negative, so that you become conscious, you become aware of how to write the ions of this atom. So for metal, the valency is the number of electrons in the outermost shell. For non-metals, you want to be careful, because by standard generally accepted around the whole world, when you hear valency of non-metals, by standard, it is really not, take note of that, it is really not the number of electrons in the outermost shell. It is not for non-metals. Because usually if you see the valency of non-metals, it goes with negative. So for non-metals, the valency is obtained from subtracting 8 from the number of electrons in the outermost shell. Valency of non-metal is obtained by subtracting 8 from the number of electrons in the outermost shell. And that always gives us a negative result. And you see, whenever you're talking about valency, just have it in mind. Valency, when it comes to elements that can react, can either be 1 or 2 or 3. For metals, it is 1, 2, or 3 positive, which is simply the number of electrons in the outermost shell. For non-metals, it is -1 or -2 or -3, which is obtained by solving the number of electrons in the outermost shell -8. So understand this now. Valency. We have valency of metals, how to get it. Valency of non-metals, how to get it. Separately. I said something at the end of this note here. Let us now assume that we no longer want to differentiate. We don't want to differentiate between metals and non-metals when talking about valency, when talking about combining power. Okay, I just come to you generally, right? How do you get the valency of an element? I just come to you and say, how do you get the valency of an element? If you tell me it is simply the number of electrons in the outermost shell, I will okay it. I will okay it. It is not left for the examiner or whomever that is assessing you to be somebody who understands chemistry for what it is. Because there are cases that non-metals, we use the number of electrons in the outermost shell in their chemical combination. Yes, in forming a compound. There are cases it happens. Look at this compound. P2O5. Phosphorus 5 oxide. In the reaction here, phosphorus uses its 5 electron directly in the reaction. But although at the end of everything, if you look at the atom, there is 5 minus 2, okay, you get 3. And anyway, let me not go into that. Just have it in mind that in this case, during the combination, phosphorus transfers its 5 valency to oxygen. And phosphorus is non-metal. Oxygen is also non-metal. So whenever you have two non-metals combined, usually one of them will make use of the number of electrons in its outermost shell as its valency. So I think this is a a function of an examiner now to really understand chemistry for what it is. If you throw the question open like that, how do you obtain the valency of an element without stating for metals and for non-metals? One can just conclude it is the number of electrons in the outermost shell. And under that case, the examiner should okay that answer. But if we now become specific, you want to take note that for metals, it is the number of electrons in the outermost shell. And for non-metals, it is the number of electrons in the outermost shell minus 8. All right. Antares 444, I hope I have been able to answer your question. Phosphorus minus 3 and 5. Yes. Phosphorus has the valency of minus 3 and 5. That is still what I am explaining, or I've been explaining since. But now let me make this even much more clearer and shock you. If an examiner gives you this question, what is the valency of nitrogen? Valency of what? Nitrogen. Because nitrogen and phosphorus, they belong to the same group of the periodic table. Valency of nitrogen. And then in the option, you have option A, minus 3. Option B, 5. Option C. In fact, let me leave it at these two options. If you select B, you will be marked wrong. You will be marked wrong. Take note of that. As long as these two options appeared in the question, in the option rather, the correct option will be A. Because nitrogen is a non-metal. So by standard, the valency goes with negative. It's only in rare cases that you will see nitrogen with valency of plus 5, which happens when when nitrogen is combining with an element that is a non-metal and strongly electronegative. That goes with phosphorus as well too. If this were to be phosphorus, if I ask you what is the valency of phosphorus, and in the option you have minus 3, option B 5, let's say option C 6, option D 7, the correct answer will be A, minus 3. If you select B, you will fail it. Because by standard, the valency of a non-metal goes with minus. So although you have this, minus 3, and you have 5, 5 is the number of electrons in the outermost shell of phosphorus, as well as of nitrogen. By standard, that is not the valency. That is not. Like I said, we only take that number of electrons in the outermost shell if and only if that non-metal is combining with another non-metal that is strongly electronegative. See, there are certain things I don't want to go into emphasizing yet, because we'll meet some of them on that periodic table as we are moving on in our chemistry class. But let me repeat this again. The only time we consider the valency of non-metals to be positive, the number of electrons in its outermost shell, is only when that non-metal reacts with another non-metal or combines with another non-metal that is more electronegative than it. I will conclude this part of explanation by going back to this example, phosphorus 5 oxide, P2O5. Now, phosphorus is a non-metal. Oxygen is a non-metal. Both of them have combined to give us phosphorus 5 oxide. I can ask you, what is the combining power of phosphorus in this compound? The answer will be 5. In this compound, phosphorus is not using minus 3 to combine. It is using plus 5 to combine. And why is that so? It is because phosphorus here has combined with another non-metal, oxygen, which is strongly electronegative than it. Oxygen is more electronegative, is more negative than phosphorus. You know, oxygen is in group 6, phosphorus is in group 5. And you know that electronegativity increases across the period from left to right. It increases this way. Now you will cross group 5 of the periodic table before you go to group 6 of the periodic table. Oxygen is in group 6, phosphorus group 5. So oxygen is more electronegative than phosphorus. But both of them are non-metals. So if they are combining, one of them will be acting in a metallic manner, which is phosphorus in this case. That is why in this compound, phosphorus will be combining with a valency of +5, which is the same as the number of electrons in the atmosphere. So if we do not go to specific cases, you cannot, I repeat, you cannot say, and it is not allowed to say, that the valency of non-metals can be positive, is positive the number of electrons in the atmosphere. It is not allowed. Remember, what I told you is generally accepted. It is only when we become too specific in cases that we can now talk about, okay, let's leave it as number of electrons in the atmosphere. It's only for metals that the valency is number of electrons in the atmosphere. For non-metals, no. I hope I've been able to deliver this answer to your satisfaction. And Therese 444, and you say, thank you, sir. You're welcome. I'm glad you understand this concept. Please, let us move on. Let us move on. Now, what have we learned so far? You can see that all these things we did, no matter that the note is quite short, the knowledge here is absolute in a sense and very much important. However, where did we get all these things from? We got them from valence electrons. Let me check what the time is, please. All right, we are just 53 minutes gone. This is a 1 hour, 30 minutes class at most. We may close before then. We may get to that 1 hour, 30 minutes. If I don't finish the class within 1 hour, 30 minutes, of course, we have another part of this particular class. You don't learn one day. You know, schools have just resumed, and I think fully it will be resuming from 13th. Yeah, fully to say that every other schools will resume from 13th, you know, which is coming Monday. When school resume, do you just go to school and learn everything one day? No, learning is an art. It's a step-by-step process, you know. So never expect to learn everything one day here. It is gradually. Let's go to chemical formulae. Chemical formulae. But before chemical formulae, let's talk about radicals quickly, please. I've given you the idea of how to get valency, you know, so you can actually on your own find out, determine it at the end of this class. Go and do your work. The first 20 elements get their valency. However, don't overbother yourself about valency of group 4 element, valency of group 8 element. Let me just tell you. For elements that have 4 electrons in the outermost shell, the valency is simply 4. Then elements in group 8 that have 8 electrons in the outermost shell, their valency is 0. Those ones that their outermost shell is complete, their valency is what? 0. That is why they do not combine. If you hear of noble gases do not react. I've been talking about group this, group that, for those that do not understand that very well yet, especially those in grade 10. Yes, in Nigeria here we call them SS1 students, those that have just entered SS1. Don't worry, the idea of group and period, you will learn it as we move on in our classes on the periodic table. It is just out of the situation on ground that I had to make reference to them. Let us talk about radicals. Like I said, please determine the valency of every other element among the first 20 elements. But that of carbon, silicon, forget about it, is 4,4. That of helium, neon, argon, forget about them. Those ones are zeros. Are you following? And they are not much of our problem. They are not. They are not. But for the other ones, yes. I think the other 15 of them, the remaining 15, I've eliminated carbon, silicon, I've eliminated helium, neon, argon. Okay, so the remaining 15 elements, go and find out their valency. Write it out in your notes. However, on this channel, under our inorganic chemistry playlist, Chem 101. You have a video lesson there, pre-recorded, where I've already taught that, and it's available on this channel. You can also make use of it to be able to get the valencies of the first 20 elements. Let's go. Radicals. What are radicals? We define radicals quickly as group of atoms of different elements. Group of atoms of different elements that possess electric charge. Radicals are group of atoms of different elements that form a single unit with an ionic charge or with an electric charge. It's just like the way we define ions. Ions are atoms that possess electric charge. Generally, ions are atoms or group of atoms that possess electric charge. That electric charge is the valency that we just concluded. So radicals now, radicals are actually ions. But the difference between radicals and normal ions that we know is that if you talk about ions generally, we usually think of one atom. For example, you could have something like sodium ion, chloride ion, you could have oxygen ion, you could have hydrogen ion, you could have magnesium ion, you could have aluminum ion, you could have nitrogen ion. These are ions. Each of them are just single, they are obtained from single atoms. Now, when I give you something like this, it's an ion that has this special character. Why? These guys now, they possess this charge. They possess electric charge. They have the ionic charge like these ones. But the difference between these ones that you have here, are you following, right? The difference between these ones and this one here is that this guy contains atom of different elements. This is atom of oxygen. Atom of the element oxygen. This is atom of the element hydrogen. But they come together to form a single unit. Because like in this case, you can't split the oxygen from the hydrogen. They come together as a single unit with this electric charge. These are the ones we call radicals. You have something like this, NH4 plus, could have something like CO3 2 minus, and the rest of them. So why all these things are ions? They are all ions. Specifically, we refer to these ones as radicals. Radicals. You can't call each of these radical. You can't, because they do not contain atoms of different elements. They don't. Having said this now, let's still redefine our radicals. We define radicals as these are group of atoms of different elements. Atoms of different elements which form, these are groups of atoms of different elements which form a single unit, with an electric charge. So you must see them with plus or minus as the case might be. Examples of radicals include, must I give an example of radicals here? No, I wouldn't. Rather, we are going to tabulate some radicals, and then because you need to know these radicals and their names. You need to know these radicals and their what? Names. But let me save our time. I wouldn't give the whole radicals and their names here. When we get into maybe how to form correct chemical compounds, I may not mention them. Why I won't list them in tabular form with their names and valency is because on this channel, I have a pre-recorded video lesson already that covers that under valency. Please Try to explore this GMAT 41's channel. Explore it. You will be wowed by what you see here. You'll be amazed. If not for anything, yes, not bragging, with total humility. But man, I must tap my chest and give the credit to our God and helper Jehovah. I have done wonders as a single person. Yeah, a single educator. Something that I don't know how many persons have done that. And I still keep delivering. I say this with total humility. And I'm saying this to encourage you, friends, so you make use of this channel very well, please. Almost everything you need in your studies, they are available on this physics, chemistry, maths on this channel. Make use of the playlist. If you go to the playlist section of this channel, locate Chem 101 in organic chemistry, you would see in tabular forms our common radicals, their valency, as well as their names. So let me just write, e.g., we have OH negative, we have NH4 positive, we have CO3 2 minus, we have SO3 2 minus, SO4, okay, 2 minus, we have SO4 2 minus, we have Cr2O7 2 minus, we have MnO4 minus, we have NO3 minus. Okay, at least I've done you well listing almost all the examples of our common radicals. And you can see their valencies written on top. Yeah, their valencies are this ionic charge. This is hydroxide ion, hydroxide radical. This is ammonium ion, all right, ammonium radical. This is trioxocarbonate 4 ion, all right, trioxocarbonate 4 radical. This is trioxosulfate 5 ion. Trioxosulfate, is it sulfate 5 or sulfate 4 ion? Trioxosulfate 4 ion. That's what you have here, trioxosulfate 4. This is tetraoxosulfate 6 ion. Tetraoxosulfate 6 ion. This is heptaoxodichromate 6 ion. Heptaoxodichromate 6 ion, or heptaoxodichromate 6 radical. This is tetraoxomanganate 7. Tetraoxomanganate 7 ion or radical. This is trioxonitrate 5 ion. Trioxonitrate 5 ion. Like I said, if you want to have a note of it written in tabular form, please access the GMAT 41 video lesson on valency, pre-recorded. Go to the playlist on Chem 101 on this channel. So this is much about valency. Now I want to take note of these. You can store this information in your kidney or in your liver, right? All radicals are ions, but not all ions are radicals. I repeat, all radicals are what? Ions, but not all ions are radicals. It is just like this idea under acid, base, and salt. All alkalines are bases, but not all bases are alkaline, okay? So the same thing here. All radicals are ions, but not all ions are radicals. Of course, I've told you before I define this. Ions are just individual, atoms of an element carrying electric charge. And ions can also be group of atoms of different elements carrying electric charge. But if it is single atom with electric charge, you can't call them radicals. You can't. You only refer to them as ions. But if you have a group of atoms of different elements with electric charge, specifically we refer to them as what? Radicals. So once again, all radicals are ions, but not all ions are radicals. Grace Mba, she says, thank you, sir. Thank you for appreciating what we are doing here. You're welcome to join GMAT 41. Please remember to always stay tuned to this channel. I will help you, friends. I will. GMAT 41 believes that I think we should offer better form of education and that no child should be denied proper learning. I don't believe in the fact that, oh, this person does not understand this subject or whatever. No subject is beyond understanding. That's the truth. It's all about how the person is being taught. And I've decided, if not for anything, I can give to humanity within the time that I still breathe, the breath of life, to expose, if not for anything, our basic aspect of sciences, because these are the basic aspects as you kick off. From SS1, SS2, SS3, 100 level, 200 level, yes, I'll continue to give you the best. But then you people should always remember to support this channel. How? There are different ways you can support the channel. Subscribe, turn on your notification bell, select all after you turn on the notification bell. But subscribe, very important. Share our video lessons. Share it to your friends. Encourage them to visit the channel and subscribe. Someone needs you to tell him or her, about this channel, to believe in what this channel has to offer. So encourage them to join. And of course, there is no single person that will come to this channel. If the person is serious with education, with learning, that will not appreciate what is happening here. That's the truth. Okay, so by this way, you can support this channel, share our videos, let it go viral, encourage people to subscribe so that this community will grow. Let's become, many as a family. To you loving subscribers that have subscribed already, thank you so much. Thank you for the support. And you can go further on your own to become channel member. Is a way of supporting us more. Okay, you can join our platinum level or diamond level. That one now is on your own. You pay monthly. All right, you pay monthly for that. But of course, pay. Now you support us financially. You support us financially. Platinum level is 2,000 monthly. Diamond level is 4,000 monthly. Okay. This levels also contains certain specific videos for channel members. So you gain more benefits on these levels as well too. And more so, you can just send GMAETS for the one super thanks. Below any of our video you have this icon that YouTube has provided for you, report thanks, straight in thanks. If you click it, you'll see different packages of whatever amount that is convenient for you, which you might wish to use in supporting this channel. I will sincerely appreciate. Thank you in advance. Let's move on, please. Once the student has learned about valency and has learned about radicals, remember, it is the knowledge of valence electron we are using here. By the way, before I forget, another way of supporting this channel, always like our lessons, please, our videos, like. Once you cross anyone, whether you watch it or not, like it. Because, of course, whatever I do on this channel is something that affects life positively. That's the truth. It's purely academic work. So please, like, leave your comment. Because the more you like our lessons, our videos, the more you comment, you give YouTube the opportunity to share the video to many others, to recommend it, okay? Please, I'll really be grateful for that. That's much I'm asking of you, friends, please. Okay? We've used the knowledge of valence electron to learn up to this point. So I am saying that with just valence electron, there are so many things you can learn in chemistry. How did valence electron actually lead to all these valencies you are seeing here? How? Think, for example, how did we get this -1 as the valency of OH? Please take note. This minus is not affecting only hydrogen. No, it is both of them, OH and then negative. Are you following, right? But we don't usually put it in bracket like this anyway. We just write it this way. So all these valencies you are seeing is affecting the two atoms in the radical. How did we get this -1? Let me quickly show you that it is from the knowledge of valency. Oxygen has a valency of -2. I've already said that before. Hydrogen has a valency of +1, although hydrogen can also have a valency of -1. But the valency of hydrogen can only be -1 if hydrogen is combining with a metal. For example, in this compound, sodium hydride. Sodium is metal. So this hydrogen is playing a non-metal character here. The valency is -1. And here for sodium is +1. Are you getting me right? So when hydrogen combines with a metal, its valency will be -1. But if it combines with non-metal, its valency will be what? +1. In the case of this radical OH, Oxygen is a non-metal, so the valence is -2. Hydrogen will now be purely metal as it's meant to be. Because when you are dealing with metals and their compound, hydrogen comes under there, you know. So if you add these two guys together, what will you get? -1. This guy is from oxygen, this one is from hydrogen. So both of them combine to give you OH. You see that the overall valency is now -1. Am I communicating? I love chemistry, you know, and I love science generally because science is interesting. You deal with things with facts. You are talking, you are breathing this thing, and you are proving it. Good enough, God has created all these things, and kudos to the great scientists that have worked out all of these things for us. We're grateful that as we are studying these things, it's making sense. We could see how they actually got all these things. I've shown you how we got this minus. Perhaps the one that usually confuses students sometimes is this one, SO4 and 2 minus. Why is the valency of tetraoxosulfate 6 ion -2? Why? Because you see, S is in group 6, sulfur. Oxygen is in group 6. So if these two guys, combine, if both of them are in group 6, their valency is supposed to be -2 and -2. So if from this other one I did of OH, I added their valency. If you add -2 and -2, we should be talking about -4 as the valency of this SO42 minus combined. Why now is it that the valency is -2? Like I said, whenever any two atoms combine, one will be behaving like a metal and the other will be behaving like non-metal. That is it. It is a natural phenomenon. That is why even the Bible says God made them man and woman from beginning, right? The opposite sex. Am I communicating? You study that in biology, which leads to the fact that organisms are opposite. They gametogenize, reproduce, and bring an offspring. If you have the same organism per se, you don't expect that combination to take place. So one must have this opposite character. That is the whole idea. So let us come here and see, how did we find out that this is -2? How did we get that -2 in this SO42 minus? I'm going to show you. The valency of sulfur in this case will be +6. And then the valency of oxygen in this case will be -2. Okay, this is interesting. I love this maths. As we move on in this class, I am going to teach you how to calculate oxidation number. Oxidation number, you hear a calcium trisulcarbonate 4. You hear something like sodium heptaosodichromate 6. You hear something like potassium tetraosomanganate 7. All those numbers, where do they come from? Under oxidation number calculation, I'm going to teach you that. Are you following, right? So let us look at this. Why is the overall valency of this SO4 guy, why is it -2? I'm going to show you. Like I say, sulfur, the valency here is +6. So do you see that sulfur is behaving metallic? Because it is metals that have positive valency. And then I said that oxygen is -2, meaning that oxygen is behaving as a non-metal here. It's carrying negative. Network is hanging. At this particular point, network, you're supposed to respect yourself. Because I'm trying to explain something very important. Okay. We're coming to the time during which network goes down. So let us do a round off. Oxygen is behaving as a non-metal here. Oxygen is behaving as non-metal here. Sulfur is behaving as a metal. Why is that so? How did I even know sulfur is behaving as metal? Look at it is using its +6 valency. And metals have positive valency, Oxygen is using -2. The minus shows it is what? Non-metal. But I told you that both of them are in the same group 6. So why is it now that sulfur is behaving metallic in character and oxygen is behaving non-metallic in character? Answer is simple. Again, we use the knowledge This thing seems to be hanging. Please tell me, is the network okay at your end? Because it seems to be hanging here somehow. If it is, let me boost the network a bit. But it's just hanging and releasing, hanging and releasing. So just freeze me and unfreeze me. Okay, network is stable. Thank you very much, Chinedu, for telling me that. So let me continue. It could be from this end. Now, the reason for why we are taking sulfur to have metallic character in this combination here, even if sulfur is non-metal, is because of this property called electronegativity. I think that guy is another guy in chemistry, but of course we will meet it under periodic table. Until then, for now, electronegativity, if you come to a particular group, like I said, group 6 now, electronegativity decreases as you are going down. In group 6, the first element there is oxygen. After that, you go down. In period 2, group 6, you have oxygen. In period 3, group 6, you have sulfur. Oxygen is on top. Electronegativity decreases as you are coming down in any group. You will learn about that property when we treat periodic table. If I come to a particular group now, should I boost this network? I am a bit scared. It's just freezing, and but although somebody had said the network is stable there. If you come to a particular group and you start coming down, electronegativity, that is the negative character of the element, to start reducing. So electronegativity decreases down the group. That's what we learn. Which means the ones on top, they are highly negative. If you are going down, the negativity will start reducing. And if negativity is reducing, of course, we expect that positivity will start increasing. So if this guy is above in period 6, in group 6 rather, group 6, it means that oxygen is more negative than what? Sulfur. Which means that oxygen will be behaving as negative guy, non-metal. While although sulfur is non-metal, but it will be behaving in a metallic manner here. I hope I have communicated this idea. Now, I want to find out how we actually got to get -2 as the overall valency. How many atoms of oxygen do we have in SO4? How many atoms of oxygen? The atomicity of oxygen. Seeing it here, the atomicity is 4. So let me fix the 4 here, okay? Now watch. If the atomicity is 4, if you are solving this is +6. Now do 4, which is the atomicity, times -2, which is the valency of oxygen. 4 times -2 will give you -8. 4 times -2 will give you -8. Are you following, right? I'm still checking the network. Once it hangs me like this, I become scared of what is happening at that end. So just manage the situation for now, right? 4 times -2 will give you -8. So let me indicate it here. 4 times -2 is equal to -8. Which means you are actually adding +6 to -8. You are adding +6 to -8. 6 minus 8, or simply +6 minus 8 will give you -2. That is how we arrive at this -2 as the valency of SO4. Like I said, all this ionic charge belongs to both of the atoms there, not only one. So this -2 you are seeing here is not for oxygen only, no. In fact, this -2 here is not this one that I used in the calculation. It is the oxidation number, the valency of this radical SO4. All right, guys, I think I am done explaining all this so you understand. Okay, I think finally, look at this one, the combination of nitrogen and oxygen. Both of them are non-metals. Here, nitrogen is behaving as a metal. It is combining here with its +5 valence. That is the number of electrons in its outermost shell. It's using +5 to combine here. Oxygen valence is -2 because oxygen is more electronegative than nitrogen. -2 times the atomicity of oxygen here, 3, will give you -6. Then if you do 5 minus 6, you get this -1. All right. Once a student conquers valency, and radical. That is the only time. Once a student conquers valency and radical, that is the only time the student can withstand chemical formulae. Which means without you understanding valence electron, valency, and radical, please don't attempt this guy because you won't be able to learn it. That's the truth. You won't. And this is one of the major challenges that many students have in chemistry when it comes to chemical formulae. If I tell you that sodium chloride is NaCl now, and I tell you that if the correct chemical formula of sodium chloride is NaCl, what is the formula of calcium chloride? Possibly, out of 100% of students taking this lesson, 90, that is how bad this is, 90 may end up saying that the chemical formula of calcium chloride is CaCl. In our physical school, all right, our physical college, GMAETS 41, Special Science College, I asked this question and I was not disappointed. I wasn't, because many of them concluded that calcium chloride would be this. Because I told them that sodium chloride, the correct formula is this. But you see, this is wrong. Calcium chloride is CaCl2. How? You won't want to miss this next class. We'll spend some time. And I wouldn't want to move into this. This is going to form a class on its own, because in that class, we are going to write the correct chemical formulae of binary compounds and trinary compounds. But before you can be able to withstand that class, before you enjoy and understand that class, you should have excellent knowledge of valency of atoms, valency of radicals. That of radicals, you can see it here. And I've told you, go and write out the valency of the remaining first 20 elements. Yes, in that 20 elements, 15 of them, because I eliminated 5, you know, for you. So go and do that. If you have problem with getting to know the valency of the first 20 elements on this channel, like I said, go to the playlist. In our homepage, you'll see arrange, home, think video, short, live, playlist, something like that. Go to the playlist, click on it, scroll and scroll. Just be watching, carefully scroll. Don't do as if you are running to only. The way your textbook is arranged with table of content, I have done the works for you there with the GMAETS 41's videos. Go there and then scroll gradually. You see basic inorganic chemistry, Chem 101. Click on it. You know, playlist arrange things for you. If you click on that Chem 101, it will open. All the videos there will appear. I think there are about 89 videos or so just on that Chem 101. Scroll gradually. You'll see a video lesson titled Valency and Radicals. There are something like that. Click on it. Take the lesson there. From that video lesson, you can do that assignment on writing the valency of the first 20 elements. After that, you can still learn more about radicals in tabular form. The radicals, their valency, the name of the radicals like I gave here. Then prepare for our next chemistry class next week, Wednesday, as GMAETS 41 introduces you to how to write correct chemical formulae of a compound. You wouldn't like to miss that class. If you miss that class, I don't know what it's going to be, but I think chemistry might become quite tough for you. So make sure you arrange your affairs to be available 8 o'clock p.m. on Wednesday next week. If you have not subscribed yet, please, right away as I'm speaking now, click on the subscription icon. Click on the bell icon also after subscribing. And then once the menu pops up, click on all, select all, so that anytime I upload any content or I come on live like this, you will be notified and then you will connect to the class. Remember, like I said, on this channel, we have so many pre-recorded video lessons already. Make use of them. I'll be seeing you on Friday. Remember, on Friday by 8 p.m., we shall be taking on physics. We'll continue with our scalar and vector quantity class. Do have a good night rest. Be seeing you on Friday in our live class for physics. Invite others of your friends to connect to that class on Friday. Tell them to subscribe and turn on their notification bell so that they can also be notified once that class begins. Good night. Chinedu, thank you so much also for connecting to the class, and I hope you've refreshed your knowledge a lot. Please enjoy your night rest, okay? And then always take your studies seriously. You can come back and still watch this lesson again, because at the end of this class, as I close it, a copy of this live class will be made available. Once again, enjoy your night rest. Dream and dream and dream what? Valency and chemical formulae. Remember, under valency, don't forget to dream your radicals. In summary of what we have learned today, we have used the knowledge of valence electron to understand valency. We learned about valency of metals, which is always positive, the number of electrons in the outermost shell. We learned about valency of non-metals, which is generally obtained by solving a small math, number of electrons in the outermost shell minus 8. I explained that there are some cases in which the valency of non-metals, which is generally negative, can also be positive. That happens in unique cases where you have two non-metals combining. An example, in NO3 minus here, SO4 minus. All right? SO3 minus. And then we concluded with radicals. We stated that radicals are ions obtained when atoms of different elements combine. Usually two of them. Are you following, right? Atoms of usually two different elements combine with electric charge to form a single unit. And we learned that from the knowledge of valency and radicals, right, we can write the formula, chemical formulae of compounds. That, in the next class, we are going to deal with it. Antares 444, is it sulfur oxide you wrote there? Nascent oxygen. Sulfur oxide is good enough that you deleted what you wrote there, because you try. Don't worry. Don't miss our next class, please. Antares 444, so that you can learn more how to write correct chemical formula of a compound. This is 1:29:35. And so we are closing. Good night.